Hi there. Okay, today we're going to attempt a tag team lightning talk. So, my name is Chad, this is Rob. We're from UBC Launchpad, we're students there. And UBC Launchpad is a software engineering team that focuses on web and app development, machine learning, and cryptocurrencies. So, we rely on sort of a rotating assortment of sponsors. That means that our servers will change regularly. And as such, our deployment approaches need to be cloud agnostic. And so this is why we built this tool, Inertia. We wanted simple, self-hosted, continuous deployment in a cloud agnostic setting.
Right, so here's an example of a project or a situation we run into quite often. This semester we had a team working on an online game. And as with any game, continuous deployment is pretty important for them to get feedback and just to see if things work and to learn. And unfortunately, the process was pretty convoluted. It's not easy. It can only be done by one person. And to be honest, the fact that they got that far was pretty surprising because I know from my first project at Launchpad, I never actually got to deploying it on a cloud server.
Yeah, so another example is we'll run a hackathon, and everybody gets a free instance, which is great, and there's a big cost to actually deploying during a hackathon because time is limited. But the payoff is pretty huge because it can turn into a great demo, especially if the audience gets to get involved and interact with the app while it's running. So we kind of view that as another use case here. And we know that other solutions exist in this space for automated deployment, and many of you in the room definitely use these. But we ruled a lot of them out because either they just weren't simple enough to set and forget, they weren't cloud agnostic, or they weren't free at our scale.
So we wanted to build a tool that would be simple, easy for our teams to pick up, and just be geared towards small student and amateur projects. So this is Inertia. And yeah, I can wait for a slide. So one of our key priorities here was to make sure that it was portable. It could be used on different platforms, and we can deploy and redeploy as our providers change. So the obvious solution here was Docker. It's flexible, well supported, it works everywhere, and it's just the easiest way to deploy onto unknown environments. Compatibility was pretty key for all our design decisions with Inertia. So the daemon's written in Go to work with Docker's native client, and it's packaged in a Docker image so we can distribute it through Docker Hub. And that means we don't have to worry about platform compatibility when we're deploying our daemon. These choices allow all our setup to be complete in just 4 steps without ever leaving our local shell. In these 4 steps, we set up local configuration, we download Docker, and we start up the daemon, and then we build and deploy your project.
So what is the Inertia daemon? This is the agent running on your node. It's just a Go server pulled from Docker Hub. It has the capability to start and stop containers on the host. How do we start and stop containers? Well, currently we mount the Docker socket into the container. So this is simple. It works quite well. It's actually quite widely used for this, but it's not totally ideal. It's an approach that we're looking to change because it gives certain privileges to the container.
To build and deploy projects, we use standard Docker build procedures as well as build images. These are images that package different build tools in them, and you can run them as containers. So this allows us to build a wide range of projects without ever having to install all sorts of extra dependencies on the remote. To set up continuous deployment, which is another key feature of Inertia, it's pretty easy. You just have to register the daemon's address and RSA key to allow it to clone your project. The daemon will listen for webhook updates and update your project accordingly. Since the daemon is just a persistent server, it offers a bunch of endpoints that can trigger different actions, and our CLI will offer different commands that lets you control your project. On top of all this, we also offer a web application. Command lines aren't super friendly for most beginners, and a web application offers a much nicer interface to interact with your deployment.
Yeah, so I'll talk a bit about security. We thought a lot about it while we were building Inertia. So for sensitive setup, we use SSH. This is pretty standard, and it's secure against timing attacks and things like that, especially when the SSH commands are obviously automated. Beyond that, we'll use HTTPS with a JSON web token to communicate with the daemon. And beyond unit tests, Inertia tests integration by simulating nodes locally, running a bunch of Docker containers to test different operating systems and ensure that our initialization scripts actually work.
Right. So Inertia has achieved many of the goals we set out to achieve. It's helped reduce the time spent by our teams working on deployment by a lot, because as beginners and amateurs, it's sometimes pretty hard to work out what's going on there. But it's also been a great learning experience. The project has drawn a lot of interest from other team members who are interested in how Docker and just how deployment platforms work in general. So here's a link to our repository. If you have any feedback, ideas, or just anything at all, please give us a visit and drop a comment or two.
And bugs.